Intro.
I'll do it twice.
I do not like this.
Here.
Green eggs and ham. I do not like it. Sam, I am.
Oh, what a cop out. What a cop out. What a
I
cop
know.
out.
One fish, two fish.
Nah,
Red
say
fish,
the one
blue
you said at the
fish.
beginning of class.
What, like
That
Tweedle
big-ass
Beetle Puddle Battle
paragraph.
Battle Paddle in a puddle on a poodle?
It honestly is concerning how good you know, right?
Okay.
It's concerning.
Why? Do you know
Like,
I started, listen, hey, did I tell you guys, I started off teaching in kindergarten classroom?
I believe it.
Wow.
Honestly.
Hey, and so that's actually what we did. We did a lot of that. Damn it. Hey, I'm still recording. Okay, pay attention. All right, math.
You started, dude.
Yes.
Wow. Is your bag organized now?
Yeah, it's been
Okay. All right. So find the volume. Now I'm gonna show you guys the cheat for this, because if you guys look at it like this, everything becomes easy. Okay. Everything becomes easy if you look at it like this. So now we're gonna find.
Why?
That's a cylinder.
You're smart.
That's
Okay.
Ebola.
There's a cylinder, right? How do I find the volume of a cylinder?
Radius.
Radius.
The area of the circle times the height.
Okay, so it's going to be pi r squared
times H.
h. Okay. So now I'm going to use this same thing, but now we're going to treat it as if it is.
A big cylinder.
Okay, so now I'm going to put it on a graph now. So I'm going to sketch it as if this is a graph.
Somebody got that.
So this from here to here is what value? If I'm looking at it like this,
Half of the height.
right?
Half of X.
That's going to be my f of x, right?
Oh.
That's f of x. F of x is going to replace what value in
R.
my formula?
R squared.
R squared,
Just
right?
R, my bad. Just
Okay, so the r. So now isn't pi a constant?
Yeah.
Yeah.
Okay, pi is a constant. Very good. And the height. What do you think the height represents?
The bound.
The bounds, right? So if I'm looking at it, it's going to be pi. My bounds is the height, isn't it? So it's from A to B is my height here, right?
Yes.
A to B is my height. My radius is going to be my f of x
Yeah.
squared dx, because we're going around the x-axis here.
That's a half.
Wait. Where'd you do the H?
Yeah.
Would I do the what?
The H.
The h is the height, right? Or from here. So we're thinking about this as a cylinder. I laid it down, right? So isn't this from A to B?
Yeah. No, but I'm saying, where's the H in the integral?
Right here.
Oh, wait. Oh, yeah, I'm stupid. Oh, my fault.
From A to B is
My
from
fault.
here
Yeah,
to here, right?
Yeah, my fault. I got it.
So every time you do this, if you think of it as a cylinder, that's all you got to do. Just think of it as a cylinder, and it always comes out. Yes?
Yeah.
Okay, so as a cylinder, that's what we're going to end up with. Okay? So this is my formula that you guys have written down, right?
Yeah.
You have it written down, right?
Right here.
Thank you, because I'm erasing it right
I
now.
lost my big pen, so I don't know.
Okay, okay. So let's take a look at,
Oh, dang.
for this one right here, how would I go about setting up this one? Okay, it says find the volume of the solid revolution obtained by revolving the plane region R bounded by this, the x-axis, and x equals 4. So here, the x-axis, right? So that means that my lower bound is what?
0.
0. So right here, so this is my A, so that's 0. And my upper bound is, right?
Yeah.
So given that information, I know that it's going to be the same formula. So I'm going to have, let's see, it's going to be from my pi out front, from 0 to 4, and it's going to be my
Rad X.
rad x, there's my function. What am I doing to the function?
Squaring it.
Very good.
dx.
Square and dx. Order of operation, what am I going to do first?
Square.
I gotta square that first, right?
Such as that.
Wait, why are
And then
you
we
squaring it again?
Okay, now in the cylinder, isn't it pi r squared h? R is this function from here to here is my r.
Wait, don't we? Why?
So my f of x at every single point is the r.
Why are we squaring it? Why not? Are we not just integrating it?
Yeah, yes, we're going to. We're going to.
So we always have to remember pi in front.
Yeah, but don't
Yes, because your
like, why are we
formula,
squaring
the
it?
volume
Like before we square it.
is pi r squared h, right? That's of a cylinder. Yes? Okay, so I'm gonna draw a basic cylinder again.
But how do you know it's actually first? Or is it
I'm gonna show you right now. I'm gonna show you. I'm about ready to get there. I was just setting it up. Okay, and I'm gonna show you why. So this is the cylinder, right? So it's a cylinder. Here's my h. Here's my r. Okay, so it's pi r squared h. So we just take this and turn it on its side because we come up with this right here.
Yes, get ready for this, guys.
Okay.
That's pretty beast, not gonna lie.
So now I'm actually changing this. Let's go ahead and change a couple things.
No, I had a question.
I'm moving this to 0.
I had a question.
Yeah.
Why are we squaring it though? Like, don't we go from that? Like, can you go back?
Oh, okay. So now,
Yeah, like why are we squaring the radical x? Why don't we just start integrating it? Because like before we didn't do that.
okay. So are we squaring this? So now, if you took an integration from somewhere of x plus 2 squared dx, how would you go about solving that?
You expand it.
You would expand it first, right?
Oh, okay.
Does that make sense now?
I guess.
So yeah, I'm gonna expand it. So I'm gonna take care of that first before I do that.
Okay.
Easy?
I guess. Not.
Yeah. So I don't have anything too complicated out of here. So I just let me clear this. Okay. So let me go back to here. So now my lower bound was 0, right? And my b value should be 4.
This is
Your A is. Yeah, it's a bit off. It's a bit off, sir. There's
Okay.
nine.
Now,
0.5.
because this is what's going to happen as I do this. It's going to give me, yeah, for this right
A
here.
bullet.
Now, does that make sense?
yeah.
So we're finding the volume, but it's not a cylinder anymore, right? Because of this function right here, it's not going to make it a straight cylinder. It's curving the line now,
The f of x is changed.
right? The f of x changes at all points right here.
What happens?
Okay, and because it's changing at all points, we have our circle that we're having, right? This is my f of x. My f of x keeps getting bigger as I go. It keeps changing. It's increasing, right? So that means that, you know, the whole thing is like a bell shape. So the bottom of it keeps getting bigger. So my f of x is getting bigger as I'm doing this, right? So with my integration, I had to find the area under the curve, and then I take this and I found the area and I rotate it, and I rotate that area over this to get a solid out of it. Okay, that was part of my notes right there. Let me stop this one. Part of my notes, it says volume of a solid. Oh.
What would be a real world application of this?
Real world application. Okay.
Yeah.
I don't have it on here. We're finding the volume of some shape. So, you know, there is a lot of the stuff in the book that they have is
like
actually
a-
like machining
So like a pool?
or yes, stuff like that. So you're actually you're finding volumes of like weird shape. Yes, you're right, like a pool, because none of the pools have like the flat bottoms.
Yeah,
A lot of
like
them,
they go like whoop.
yeah, like one of those home pools that you have the bottom is like 8 feet deep, and
Yeah,
like the
that's not
shallow
mine.
end goes up to like 4 feet.
That's not mine.
Yeah.
Okay, because there's a curve there. Okay, stuff like that. So you could mathematically model it by what we're doing here.
I take that with
Make sense?
No.
Okay. All right. So now for this one,
C.
So keeps going.
Is that purple? What purple?
So I changed this problem. This problem was actually a slightly different one, but it's still doing the motion for that I was looking for. Because eventually we're gonna actually get to the point of this here.
Oh yeah, that looks bull. Not gonna lie.
And so we're moving. So we're gonna rotate it around other things.
So we have a hollow center.
Yeah, hollow center. That looks really bull. Not gonna lie.
So would it be the area of, let's say?
Also, will we make another cylinder?
It's the volume.
It would be it'd be the volume, right? And you would subtract the cylinder in the center.
Excellent. Yes. So it'd be the volume of the outside minus the inside, and that would be it's actually washer method.
So would we do another integration for the or
Yes.
another
So you would
integration?
subtract
Oh,
the inside part,
that
right?
made- That made.
I like that.
That'd be
Okay. Does that make sense? Okay. So now let me reset all of this, and so the work for this one, which looks like this.
Oh, what the heck?
We're getting to this, but like I said, this is for a problem that we actually have down here.
Cute.
Okay, this is the work for one that's not around the axis. So I changed where this is so we could actually match what we have.
Does it work change or no?
No, the work on this one doesn't change. Okay, I don't think so. Anyway, all right, so let's go back to this. Let's go back to what we're doing here now. Okay, now that you have a visual, you have a concept of what you're actually trying to do now, right? So I'm going to erase my volume.
Flex.
Now, do you understand why it's now squared? My pi r squared, because that's the volume of the cylinder, pi r squared h. And for each one, my f of x is right here, right? So that's my radius of each one of these.
Oh, is the bottom one supposed to like be a diagram of?
Yeah, diagram of it, but it's kind of hard to see. It's a two-dimensional, and that software actually maps it three-dimensionally
Wait,
for
what
you.
software is that?
It's GeoSketchPad.
You have to pay for it.
Yeah, you could find it. This is like a 1990 version or something like that. Yeah, it came out like early 2000 or like 98. It's very old.
Wait, can
Anyway,
we see how inspired?
all right. So
No.
right here,
No, no,
let's
no.
take a look at this. Now, if I'm doing my math, I would square that first. So it's going to be what? So it's going to be pi from 0, 4 x dx. So I get x squared over 2 from 0 to 4, and don't forget the pi.
8 pi.
So it's going to be
4
8.
squared, 16 divided by 2 is 8.
So-
Minus 0.
So it's 8, so it's going to be pi, right? And it's going to be 8 minus 0. So my answer is just going to be
8 pi. Sausage. That's the area for the cylinder.
not area,
The volume. Sorry.
volume.
It's the volume.
The balloon.
The volume.
Room.
It's a balloon.
Okay, questions?
Comments, concerns.
Is this pretty neat here?
I think it's
Not gonna lie, the software made it cool. The math didn't, but the software made it cool.
So yeah.
I remember when the lights in the door broke it
Oh
up.
wait, can you do it with cubics?
Yes, you can. So we're going to get weird stuff that we're going to end up actually.
Those would look so cool.
Wait, can we do one for an example? Let's do it.
So you talking about this one right here?
Oh yes.
Okay, but now, but this one's bound, isn't it?
Yeah.
Okay, so this one is bound.
They some jerks.
But now, what is this doing now?
Find the volume of the solid energy.
So now this one is different because this is about what? Y-axis. Very good. So from right here, it's going to be bound from here, here. So this is my lower bound here, right? So this is my A. So now this is my height now, isn't it? Okay, and what is my B value?
3.
3. Okay. All right. Let me change the A to a 0. Okay. So for this one right here, my values, this is going to be a dy because I
We're
am.
doing it with respect to the y.
respect to the y value, right?
Is that, so, quick question. For the AP, does that matter? Are they looking for dy, or do they just look for
Yeah,
to
dy.
match? Or are they looking for them to match? Like,
They're
okay,
looking for dy.
Your
like my
Your stuff has to match. So think of it, if you're doing like a related rate, remember related rates? It was a
dt.
dx dt or dy dt, right?
Yeah.
Those, they have to match with what we're talking about.
even if all the math is correct.
All the math is
my,
correct.
My formula and my d something is the same. Okay, never mind. Honestly, I'm gonna just.
For example, for the short answer, they would take off points for not having the dxdt, but if you get the right answer,
You still get points,
But
but
you'll
if you
lose some.
didn't actually label everything correctly,
You'll
then you
lose
do
some.
lose something.
Yeah, okay, like so if I put x cubed dx,
they want you to be precise.
then I lose points for not putting dy instead of d.
Okay, so now if I'm doing this in respect to
We
the
have-
y,
we
for
gotta
y.
solve.
We have to get x by itself, which is just rad. The cubed root of y.
That man.
or I could just say x
To the-
equals.
Y to the
1/3.
1/3.
Can you integrate in your
Can you integrate integration?
like? I'll ask you later.
Double integration?
Yeah.
Yeah.
Like in the calculator, you just put them.
Yeah, there's double integration
You're
too.
lying.
Anyway, alright, so y-axis, okay, so now let's take a look. What is this going to actually look like now?
Pi integration 0 to 3 1/3.
So it's
Y.
going to be, let's take a look,
Y to the 1/3 squared.
pi,
Oh, ooh.
and it's 0 to 3,
Y to the 1/3
y to the
Negative.
1/3
square.
Square. Qué chido.
dy.
dy.
Está machín.
Okay, let's see if I could, is it this one?
No.
No.
I actually have one for this, so I'm just trying to find out where I left it.
That one? No. No.
Oh, here it is, yeah.
What?
It's not the same function though.
Oh, okay.
But it's one with respect to y.
And so, yeah, so this one's going to be respect to y. Ah,
Oh, not movable.
it's an undo.
Control Z.
Control Alt Delete. Just start fresh.
Undo translate.
When this square we have
Okay.
power, right?
So I'm changing my a.
If an exponent is being raised to another exponent, you multiply.
And then,
So 2/3.
That's what it
You should add.
But in my head.
oh wait, wrong one.
Me.
There's
That's what I
another one,
thought,
hold on.
but my tongue thing and my mouth
Shut
thing
up.
did not communicate. Did not. What the
Ah.
heck is this?
No, it's all eventual. It's actually not bad. Look, here, revolve. This is basically what we're gonna do, but this is a y
That is so cool.
around the
That looks like
non.
That looks like the thing downtown.
Yes, it actually is.
Yes.
So
Okay.
we are gonna do this, but I'm just trying to
Real life situation right there.
I'm trying to find the
Wait, what?
revolution one.
Wait, what?
Shut up.
Okay, I can't find it now.
Uh,
I had it because I had like a whole bunch of them open.
wait, can you go back?
Hmm?
Go back to the software.
Oh no, because I already have a bunch of them open, and I think I closed that one because I have some of them that because I only could open one page at a time, and that one just had a bunch of tablets or tabs, so I just used that one for the first one. I couldn't remember what I did with the next one. So anyway, all right, so let's go ahead and do this one. So it's gonna be what?
2/3.
Okay.
As the exponent.
So it's going to be pi 0, 3 y 2/3 dy. So pi 0, 3. Oh, wait. Actually, no. Let's do that integration.
5/3.
So pi, and it's going to be what?
3.
Y to the
5/3 or 3y to the 5/3.
3 over 5 5/3 from 0 to 3.
Oh, thank God it's a 0.
Nah. Some of them look nasty, but still, life goes on. All right, so what's that gonna give me? What's 3y to the 5th? I know y to the 3 to the 4th is
Plug it in the calculator.
2081
Do you want a fraction or decimal, sir?
243.
243
Fraction or decimal?
fraction.
Sir? Got it.
So it's 243.
Oh, what the heck? Oh no.
The cubed root of 243 times 3.
I don't want to put that. I don't want to put that as a fraction calculator.
That's more than one. So that's going to be 3, 9, 9/5. So it's going to be pi 9 over 5.
Wait, what?
And that's going to be the cube root of, there's 2 over squared, 3 squared is 9, 9
What?
minus 0.
Wait, Pacho. Where did that extra 3 come from to make the 9?
Okay, so look at this, watch this.
I'm watching.
So 3 over 3, right?
Yeah.
And that's 3 to the 3 over 3 times
Oh.
3 to the 2 over 3.
Okay.
Oh.
I like
Because if this was 3 over 3, wouldn't that just be 1, right?
Yeah.
And this is to the first power, so I could actually separate my powers like that.
Nice.
Because I always add exponents, right?
Oh.
I always add exponents. So if I add those together, I get my 5/3, don't I?
It just clicked in my head. Oh my God.
And get 5/3.
I got the
And then
wrenches.
there's 3 different 3s.
Yeah, so I took care of that. So because that's more than 1, and so I could take out 1 3, and there's a 2/3 left over. So that gave me the cube root of 3 squared, which is here. So I get 9 pi cube root of 9 all over 5 as my
Volume.
volume.
That's pretty cool.
I don't know. What do you approximate that as? Something, right?
Yeah.
3.744150. Oh wait, never mind. I didn't multiply it by 5.
Yeah.
Okay.
Yeah. Wait.
11.7625969.
Okay. Anyway,
Do you want a fraction point?
not really.
We want
I'll
the
do it.
approximation
I'll
then.
do it.
Not really. You
Wait,
can approximate
so-
it, but
Quick question.
what?
If you plug it into the calculator and then put with the calculator's fraction, is that wrong?
What?
Well, I did that. But it beat it. Is that wrong?
Oh yeah, don't do
No?
Yeah.
So just do this way. Do
Yeah.
This way.
that. Okay, so this is right here, bounded by this. Now this one right here is, so to show you here, here's my x-axis, and this is my 1.
Oh yeah, hold on. Wait.
This is 1, and it's now rotated about y equals this. So instead of, so let's go back to my graphic. Is this one it? Nope, it's not that one. Oh, there it is. There it is. Okay, so this one I can't. I was gonna try and change this, but it wasn't working out for me. I'm really not very good with these things, so I don't know how to actually like
The
work this.
software?
Yeah, I can't change what they have there to like make your own to actually do that. So, you know, I just go with what someone else has. So now for this one here, I'm gonna show you example. Now this is what I was saying. So remember how I said you can, here's the axis of revolution. Okay, and if I change it to this,
We get that cylinder.
Okay, right here, right? And it gives you a hollow, right?
Yeah.
So that's a washer.
My washer, my
That's a washer. Now, it's the same thing, but that's top minus inside. So now for here, now what we're doing on this one, we're actually changing it by going up.
this one should
We're changing it by going up. So now I'm not expanding it. There's not going to be a hollow. There's now,
Gonna be spare.
be like
Extra.
thrown in
There's
there.
gonna be extra.
It's the cone.
and now we're talking about this cone right here.
So will we take the volume of the cylinder and then subtract?
Okay, so now think about your radius. Your radius is the key on this.
The radius is still f of x.
That's what it is.
Someone yelling.
I know. I'm getting worried.
Quarter popo.
I am.
12.
Okay. All right. So now, for what we're referring to is just this little piece right here. So now, the key thing about this is my radius. My radius is what's important here, right?
Oh wait, it'll be half of the f of x, right?
So if it's the f of x,
I will.
and now am I increasing the radius or am I decreasing the radius?
Radius.
So what do you think I should do to my radius here?
Make a negative? Wait. No. Oh, that helps.
Half.
Did it change?
It halved it.
Did it change it here?
I th-
No, it didn't change it. This is still from the previous one, the one that was original for that one. Okay, so now, in this case, it halved it, but I moved this to 1, didn't I?
Yeah.
If I move it to 1, that means that my radius has now gotten smaller, isn't it? So basically, this radius is. Now, give me the formula. Okay, how would I say this?
F of x plus
F of x
divided
Half of it.
F of x divided over
Oh, f
2.
of
is f of x, but now,
Times
right?
1/2 or
It's only from here to here, right?
yeah.
So
From 1 to
no, think about it from here to here, right?
2. Minus
So it's
oh, is it 2?
f of x
minus that.
minus.
F of
Is this one? This is 1.
yeah.
Oh, wait, oh, that's 1.
So if this is 1, now it'd be my radius is my f of x
Minus 1.
Minus 1.
minus 1, right?
Okay, that makes it simpler.
Yeah. So the radius is f of x minus 1. Does that make sense now? So if you see it like that, it's f of x minus 1. So let's go back to my notes on this one. So for this one, I have this function here,
F of x plus 1.
right here. So that means that if this is my axis, right, I am rotating around this. Okay, the same thing. So now, because if this is my x-axis, my function should look like this, right?
Oh, that's what that is?
Yes.
I was so confused on the graph. I thought
It's
that
all
was-
right. It's all right.
that was-
Okay. So it's my, for this case right here, this top piece is my function, isn't it? Right? And if it's rotating around y equals 1, that means it goes up here, right? So in this case, it should be, for my radius, it would be what?
2 minus x.
F of x
Minus
minus 1. So, what is this piece here and here going to be? What is those two things?
1.
Because it's bounded by this, right? So when is my function on this side equal to 1?
1. 1 and negative 1.
Very good. It's at 1 and negative 1, right? So my x value is negative 1 here. My x value is positive 1 here, right? So I use this function to figure out where it's going to be equal to that. So from here, it's going to be negative 1 on this side, positive 1 on this side. So if I do that, let's see. If I plug in negative 1 here,
Negative 1 squared is 1.
yeah, so 2 minus 1 is 1. That's what I'm looking for. All right, positive side. 2 minus 1 is 1. That's what I needed. Okay? So what does that tell me there? What are these numbers
That's your
important
bound.
for?
That's our bound.
Those are your bounds. Very good. So those are your bounds. So if it's the volume, it's going to be pi. My bounds are from
Negative 1 to 1.
-1 to 1. Okay? And my radius,
2 minus x squared
2 minus x squared
squared.
minus 1. Why is there a minus 1?
Because that's the.
It's the radius, right? It's my top minus this right here, right? Minus the 1 because it goes up 1 here, right? So minus the 1 since I moved it up 1. What if I moved it down?
But add 1.
I would add 1, right? Okay, so, and then
Squared.
and then
Dx.
dx.
Or respectively.
So a lot of time you're just gonna have a basic thing like this. Every once in a while you'll actually see something weird where it's rotating around some other function, like y equals x or something like that. So you would actually incorporate that into this,
So that,
into your radius. Speak.
oh, no, I'm thinking of what you just said.
Okay, so think about this. This is a horizontal line.
Oh, no, I'm thinking about how you said how you'll get bounds with the other.
Like an X? That's what I'm trying to say. So this is a horizontal line here, right? Where it's just, this is y equals 1. But it's possible to rotate it around like a y equals x, going this way, right? So if it was a y equals x, I would incorporate that here because my radius of this would always be, you know, from there to there. It's always going to be the top minus the bottom that it's rotating around. But that's further calculus. Okay? So now, right here, do a little math.
Doodle ball.
Pi, -1, 1, and that's going to be
4.
2. No, it's not 2. It is, nope, try again.
3.
1 minus x squared, squared,
Ah, wait, what?
dx.
Oh, wait, I was doing it. Oh, wait, I was doing that. Oh.
Yeah, you can kind of clean that up, right?
I was distributing to
So yeah, this is going to be the radius of this.
I'm gonna say 4, right?
Okay, so now let's go ahead. Let's see what we get. So it's going to be pi from, ah crap, gotta do this first. Expand it first. Pi, -1, 1, and that's going to be 1 minus 2x squared plus x4 dx, and it's going to be pi from x minus 2x3 over 3 plus x 5 over 5 from -1 to 1. And I'll let you guys finish that up.
What was that?
Okay? Don't forget, like and subscribe.
Actually, I have one question.
You have one.